Chapter 3, conic section. Over here in mathematics 3, you all are going to learn hyperbola only. While in mathematics 2, you're going to learn circle, ellipse, and parabola. Okay. So actually, hyperbola exists in the nature and human made. Okay, one of it is like hyperbolas are important in the astronomy. Okay, so some of the comic, which is called non-periodical comics, following the path of a hyperbola. Okay, then this is called non-periodical comics. Okay, then in the human-made buildings, okay, such as uh, these two nuclear building. Okay, the hyperbola structures are said to be very lightweight. Okay, they use less material and then they are extremely strong. Okay, the some of the nuclear power plant that are using the hyperbolic design. Okay, but as you know, that is in our normal human building, we are not going to use this hyperbola design, because if you see that is, if we make it rectangle, okay, so over here the developer will not agree, because the other two side of it, we still can be building more space for the houses and so on. Okay. Okay. And then another one is in the photography. Okay, maybe years ago, that is some people love to take photo in a panoramic way. So then this is also for using the lenses of the hyperbolic mirror. Okay. So now, okay, um, in chapter 3 of your mathematics 3, okay, we are going to learn about hyperbola, how to formulate the hyperbola, then we sketch the hyperbola. Okay, now first thing is regardless you are talking about conic section in max 2 or max 3, okay, the one of the skill that you need to be mastering is the completing the square. Okay, if you look at this completing the square, okay, so let's say we have a standard equation, y equals to ax square plus minus bx plus c. Okay, so this is a standard ax square plus minus bx plus c. Okay, most of the time we doesn't care about our c, okay, because we only care about the one with the x. Okay, so the first step of the completing the square is we try to factor out the a. Okay, so to copy back the plus minus, so we have b over ax. Okay, and then after that, by default, remember the b over a, you're going to obtain a 2 over here, then you put a bracket square, and then remember this one actually is minus. Okay, regardless this is plus or minus, and this is always is a minus. What you want to going to minus whatever the location of b over 2a, and don't forget to put square. Okay, then we just left our c outside there. Okay, then normally for this topic that we need to expand out. Okay, don't keep it in an a something, so we just expand our bracket. Okay, so keep here, then we have our a, then plus c. Okay, so let us look at one of the example. 5x squared plus 5x squared minus 3x plus 7. As usual, the 7 keep one side, so we factor out the 5, so we have x squared minus 3 over 5x. Okay, then don't remember that, don't forget we have a 2 down here, so x minus 3 over 2 over 5, then put square, then minus whatever in the second term, so 3 over 10 square plus 7, and then we expand. Okay, when you expand, please a little bit be careful, this is minus, so keep the minus here. Then you do using the calculator, simplify the second and the third term, so we have this one. So we already finished our completing the square. Okay, so now we go into the a little bit introduction about our conic section. Okay, over here, I will try to explain a little bit about all four conic section you're going to get. Okay, although you are only going to learn about hyperbola, but for the introduction purpose, I'm going to tell you all about the four of it. Okay, so by the definition of our conic section, we have two types of definition. The first one is by the geometric, then the second one is the algebraic way. Okay, the geometric way, you're going to see the curve. Okay, but the thing is, by algebraic definition, you will know that how the formula are formed. Okay, so let us look at these four diagrams here. Okay, then over here you will have a two cone. Okay, and the the sharp point are pointing to each other. Okay, so how you can get the any circle or ellipse and so on? The first thing is we look at our beloved circle. Okay, if you cut the circle, okay, if you cut the cone, okay, if you cut the cone horizontally, okay, horizontally means it's along your x-axis. Okay, so you will get a circle. Okay, if you make a little bit anchor, okay, a small anchor between the x-axis and the one you want to cut, you will get an ellipse. And if you keep on increasing, okay, if you keep on increasing the angle between the cutting part and your x-axis, you will get a parabola. Okay, if you notice that is parabola didn't have it's not closed. Okay, it's an arch. Okay, it's just like a U shape or the N shape you last time you learned about quadratic equation. Okay, then we have the last one is the hyperbola. Okay, among four, okay, hyperbola is the most gritty. It took two cone. Okay, and you cut your hyperbola horizontally, okay, along the y-axis. So you're going to get two lines, okay, two curve. One is from the above cone, then you have the second one is from the below. Okay, so now, okay, that is the one from geometric perspective. If you make it in 2D, okay, the one that you already learned from secondary school is the circle. Okay, so yang bulat-bulat. Okay, so it's a circle. Okay, then after that you're going to have ellipse. Okay, ellipse is just like an H shape. Okay, the one we have an 8. Okay, actually from if by the definition, okay, later on you will know that is circle actually is a special types of ellipse. Okay, and then we go to our parabola. Actually, you already learned your parabola long time ago, but we didn't call it as a parabola. We just said that we're going to have a quadratic function. So for example, you have y equals to x squared. So you're going to have like something that we used to call it as a U shape. Okay, that U shape actually is a parabola. Okay, and then the last but not least is our hyperbola. As I said, that hyperbola is the most special among all four. It comes with a pair. Okay, it must come with a pair, two curve. Okay, and these two curves are symmetry. Okay, at the center. Later on you will see. Okay, so this is the four shape of it. Okay. Now we go to project. Okay, because the circle, no matter how you rotate, it will still remain as a circle around thing. Okay, but it's not happen to our ellipse. Okay, so if you look at this ellipse, okay, the down here is said that ellipse with horizontal major axis and the ellipse with a vertical major axis. Okay, if you look at here, okay, from the equations, okay, the standard equation of ellipse can tell you that is your ellipse should be lying down or standing. Okay, so this one I call it as a lie down. This one I call it as standing. Okay, so actually later on you you will see that is from the standard equation of your ellipse. You can know that is why your ellipse is lying down and why your ellipse is standing up. Okay. Then in our parabola or our quadratic equations, okay, and you already learned last time, whenever you have the quadratic, you will always say that your teacher will ask you what is this shape, then you will say smiling face and sad face. Okay, but most of the time we didn't talk about the other partner. Okay, so the one with x equals to y square. Okay, so normally I call this x equals to y square with a positive sign. I call it this one as a C, okay, because it looks like a C. And then this is the revert of the C. Okay, some of my students used to call it as a D, okay, because you plus here is become a D. Okay, so this is the 4 different shapes that you can get from a parabola. Okay. Okay, so now let us look at the four standard equation of the conic section. Okay, these four actually can form, you're going to have the general equation. Let's say you have an ax squared plus by squared plus cx plus dy plus e equals to 0. Okay, this one is called ax squared plus by squared plus cx plus dy plus e. Okay, even you can say that you want to have an exy plus f equals to 0. This is called general formula. Okay, because it can be fit into either one of the conic section below. Okay, so what you need to do is, so if you want to know that you've been given any of the general formula is fit to either one of it, so what you need to do is you need to go through the completing the square. So that's why completing the square is a must know skill in this conic section. Okay, after you already does the completing the square, then you start comparing the formula after you modify, compare with the form with either one of it. Okay, so let us look at this from one by one. Okay, the first one I want to highlight here actually is parabola. Why I introduce is parabola, because only parabola have one square. Okay, because if you look at others, all of them are consist of x square y square, but only the parabola either is y equals to x square or x equals to y square. Okay, so if you look at your general solution, okay, if you don't have y square or you don't have x square, so roughly you can guess it is a parabola. Okay, then after that we look at the second one, special one is circle. If you look at the circle, actually circle is the one without the denominator, but the thing is maybe you can say that if you want to force the circle to have a denominator also can, because you become s minus h square over r square plus y minus k square over r square equals to 1. Okay, so that is the main reason people saying that circle is a special type of ellipse, because if you compare the circle after we write it with a denominator, it's almost look like our ellipse. The only difference is they are not a square and b square, they are r square and r square. So it means that either your a and the b actually are equal. So when your a and b are equal, then you will fall into a circle. So circle is a special types of ellipse. Okay, so now after we talk about our circle, then we look at our ellipse and hyperbola. If you look at our ellipse and hyperbola, okay, let us compare the first equation. They are look identical, except one is with plus, another one is minus. Yes, it's correct. Okay, hyperbola is the one with a bit special. It must consist of 1 minus. Either you have x minus y square or y square minus x square. Okay, it cannot be both minus, cannot be both plus. Okay, it must be either one will be negative. Okay. Okay, now back to our ellipse. Okay, there may be someone who can notice that is the formula left hand side and the formula right hand side, they are look alike. Okay, so they are lookalike. Okay, so you no need to be thinking that the formula are wrong. Actually the formula are correct, so the only difference is A greater than B or B greater than A. Okay, so now what is the use what is the thing is indicating for A greater than B and B greater than A? If your A is greater than B, that means the length of your for the X is longer, so you're going to have a okay, you're going to have a like some sort like oval shape which is lying down, so that is our some sort like our X is lying down. When your B is greater than your A, so the Y is longer, so that means you have an A which is standing. Okay, and then later on we will discuss details for our hyperbola. What for the X greater than Y or Y greater than X, what is the indicating of these two things? Okay. Okay, now we go for the algebraic definition. Okay, so so for all the circle, ellipse, then we are not going to discuss about their algebraic definition. That will be you will be going to learn in your mathematics too. Okay, so we're going to discuss our algebraic definition for our hyperbola. Okay, what this definition said, okay, generally he said that, okay, you have a set of points, okay, so the point which is on the one, okay, on this curve, okay, doesn't matter the left hand side or the right hand side curve, okay, all the points going to a pair of a pair of the points called focus, a fixed point F, okay. The distance, let's say I have a Q here, okay, QF, the distance QF I put as an A. The distance from a Q to, okay, sorry, QFF prime I put as an A. QF I put as a B. So the difference, okay, difference here means is the magnitude of A minus B equals to, let's say, is a C. Okay, so it said that this C is constant for all the points you try to find the difference. So so what it means by that, okay, let's say you have a point here, let's say I have an R. This R, the distance from this R to my F, let's say I name it XX, then R to F prime, let's say I name it the distance, I name it as Y. So the difference Y minus X, the magnitude, actually it must be also C. Okay, so because of this thing, this definition, okay, I think in the module they have to discuss how you can build this into the formula of hyperbola, but we are not going to discuss how it get sorry, how to get the formula, because they are a little bit geometric definition which is out of our scope. Okay, so now we're going to learn some of the terms that you need in our hyperbola. Okay, so the first one we learned just now is the two fixed point, F1 and F2. Okay, so it doesn't matter whether you want to name the left hand side FF1 or the right hand side FF1. So I just put this is F1, this is F2. Okay, so now the name of these two point, it has a name, is called, if singular is called focus, if more than one is called foci. Okay, for you want to say it's a foci or foci, doesn't matter, okay, because it's not an standard English terms. Okay, so these two actually is our foci. Okay, after that we're going to learn is center. Okay, what is center? Okay, center or in Malay is called titik tengah. Titik tengah of what? Okay, titik tengah of the line segment. Okay, the line segment of our F1 and the F2. So this is the titik tengah. Okay, then after that we're going to have the transverse axis. Okay, so our transverse axis is the line that contain the focus and go through the thing. Okay, so this one is called transverse axis. Okay, then after that we're going to learn is conjugate axis, the line that is perpendicular to the transverse axis. Okay, you learn conjugate for cert and you learn conjugate for complex variable. Here we have a conjugate axis, is the complement for our transverse axis. Okay, after that you will learn is about its vertices. Okay, what is these vertices? Okay, if you look at this picture, okay, our hyperbola go through our transverse axis, okay, at one point, this intercept point. These two intercept point is called one is called vertex, more than one is called vertices. Okay, so the 2 point intercept of the hyperbola and the transverse axis, and then you can name it as V1, V2. And after that, okay, directrix or directrices, okay, doesn't matter. It's a line perpendicular to the transverse axis, and the distance from the center of the distance AE from the center. Okay, because in our module we didn't introduce directrix, but because of the next we need the directrix, so that's why I give you the definition of the directrix. Okay, what is the E over here? Actually, the E over here is electric E, e the elasticity of the elasticity. But the thing is, since the E is not being introduced into your vocabulary, so we'll just forget of the definition. Just we know that is we have two lines that have some distance from our center. Okay, then come to the not the almost the last is called latus rectum. Okay, latus rectum is the chord, okay, all the line segment that through a focus and parallel to our conic section directrix. So that is the main reason why I introduced directrix just now. Okay, so they are all, we can say that they are parallel to our conjugate axis. Okay, okay, so this is the, but the thing is you're going to learn later, there is one formula especially to calculate the length of our latus rectum. Okay, then after that, then this is the last one of our terms in for hyperbola is asymptote. You learned very long time ago asymptote. Over here for hyperbola also we have an asymptote. Actually we have not only one, we have a pair of asymptotes, okay, which is go through our center, and these two lines, okay, these two asymptotes are the boundary for the curve of your hyperbola, so make sure it will not go beyond, okay, and then definitely they are not going to meet each other. Okay, so now this is the full diagram. If you plot everything and label everything together, okay, so it looks very complicated, but the thing is actually it's quite simple because normally we didn't label so detailed. Okay, the first thing over here is you must have a center, and then you have two vertices. Then you have two focus, so you have your foci. Okay, then now you have your two asymptotes. Okay, you're going to have your two asymptotes, and then you have your hyperbola. Okay, now what is all other terms bring any meaning to you? Okay, so this length from a center to our vertices normally we label as an A, and from our center to one of the edge here, okay, our triangle is our B. Okay, then after that we have C. Okay, C is very important because the C is going to give you the length of our focus, the length of our focus from the center. Okay, so this is our C. Okay, so what is the relationship between A, B, and C? Actually, A, B, and C, the relationship is C squared equals to A squared plus B squared. So this is the relationship between A squared plus B squared equals to C squared. Okay, and then after that, what else is important? I think that's all, because directrix is not in our vocabulary. Okay, but there is one more, is called LR, latus rectum. Okay, it's the one in blue line. Okay, so then later on you will see there is a formula specially designed for the latus rectum. Okay, now we're going into why we have two different formula. Like just now I said x minus y or y minus x, because we have a pair of a hyperbola, the shape or the position of a hyperbola. Either our hyperbola is going to open left and right or up and down. Okay, so if you opening left and right, we call it as a horizontal. If you open it up and down, we call it as a vertical. Okay, so how you know that which formula fit in into, excuse me, fit in into which shape? Okay, actually it's quite simple. Okay, if you still remember just now I already mentioned, okay, the first thing here must be the right hand side must be equals to 1. So for both of them must be equals to 1. Okay, then notice that is either x minus y or y minus x. Okay, if your x is in front, when your x is in front, you're going to have the shape of horizontal, or the one who open left and right, or previously my students say it look like a butterfly. Okay, so this is the way that you can easily can recall how it's going to be or what is the shape. Okay, and if you have a y in front minus x, so you're going to have a vertical, so that I can name it as a un. Okay, the one you said smiling face and the face set face. Okay, so or the standard we can say is open up and down. Okay, so that is the shape. Okay, then because okay, now I have to remind you all that is okay, if you look this topic under from others book or whatever, you need to be a little bit careful, because you need to identify is it the formula really alike or not, because some of the books they they are using s minus h square over a square. For the y minus k, they're using y minus k square over a square also. Okay, minus x minus h square over b square. For them is the a always is the one in front. Okay, but for me that is I love the a always follow the x, b always follow the y. Okay, okay, so then I no need to remember too many things. Okay, but so that's why because of following that. And one more thing that is my h is always follow the x, k always follow the y. So all the time my center is always hk. If you notice some of the notes, maybe they will say that another one is kh. Okay, so if you want to follow that set of a formula, please follow from the from 0 until the end. Okay, don't mix up two different types of formula. Okay, after that, okay, then we have a focus, and then we have the vertices. Okay, so if you notice that is for a horizontal, okay, for the one with a butterfly shape, center, vertices, and focus, they will be on a line parallel to our x-axis. For the one open up and down, you will have your center, vertices, and focus in a line, but it is parallel to your y-axis. Okay, so from there, okay, if later on if you notice people giving you information, the focus, vertices, if they are in a line which is parallel to your x-axis, then you know that this one is a horizontal hyperbola. If it is parallel to your y-axis, it is called a vertical hyperbola. Okay, then because of our just now you already seeing that is our center is really in the center of everything. Okay, so from a center, if you have a horizontal, okay, when it is in the horizontal but hyperbola, so means that the y must be all with a same value, only they have a different x value. Okay, so how you know that? Since from the standard of hyperbola, we know that the first thing is our center. Okay, the length from our center to our vertices actually is a. From the center to our foci always is c. Okay, So that's why for the foci we have a h plus minus y. There is a minus because don't forget we have our left hand side. So from the center you minus how many unit you going to the, you move to the left is minus, you move to the right is a plus. So you have a h plus minus ck. And then for our vertices, since the length is only a, so you're going to h plus minus a. Okay, so the same thing applied to our horizontal, vertical hyperbola, which is if vertical means that our x is always the same, only have a different y, so we only look at our y coordinates. When we look at our y coordinates, okay, so it's same like as like your K move up how many units, move down how many units, okay, and the C units, okay, and then the transverse axis as since it is horizontal, so it is parallel to x axis, another one is parallel to y axis. Okay, now we go to our asymptote. Okay, so asymptote, please remember, okay, it is always standard y minus k, because our linear line we always say is y equals to ms plus c. So we start with y minus k, okay, equals to plus minus y is plus minus because we have a pair, and b over a. Okay, if you use others formula, please recall, please notice whether it's b over a or a over b. Okay, but the thing is, one way easy to remember is whenever you have y equals to mx plus c, the m is always y2 minus y1 x2 over x1. So it is always y over x. So you just remember that to take the value under your y to put at the top, and the value below your x putting at the bottom. Okay, then this is the two formula of our length of lattice rectum, 2b squared over a or 2a squared over b. Okay, this is no way to recall, so just memorize it. Okay, so now we're going into how you want to graph a hyperbola. Okay, this is only a guideline, but the thing is, for me is a bit easy to draw systematically. Okay, first thing is you need to put all, okay, doesn't matter what is the question, either it is in a general form or whatever. First thing, put it in a standard form. What is called standard form is either must be x minus h square over a square. It must be in square because what we need actually is a. We are not needing a square. Okay, I need is a, so you need to put it in a square minus y minus k square over b square equals to 1. Okay, the 1 is a compulsory. If the question don't have 1, you make it until become 1. Okay, or the other way, y minus k square over b square minus x minus h square over a square equals to 1. Okay, so then after that, from these two standard form, you can identify either it is opening vertically or horizontally. Okay, if x is first, it is horizontal. If y is first, it is vertical. So when you open left and right, it's called horizontal. So means your x is in front. If you open up and down, it is called vertical. So your y is in front. Okay, then after that, you need to plot your center. Okay, doesn't matter where is at your center, just plot your center first. Then plot the endpoints of horizontal axis by moving a unit left, right. Okay, it is okay. This one is you calculate the a. Okay, if the a over here, because my formula is a is always below my x, so the a is always left and right from the center. Okay, so then if the b, okay, the b is always under my y, so it will be up and down. Okay, so this one. Okay, so how many unit? Okay, then this one is going to recall what is called transverse axis. The transverse axis is the one, the segment joining the vertices and the center. Okay, so For this one, this is the transverse axis. For the horizontal, this is transverse axis. So the transverse axis is not necessarily must be parallel to your x-axis. It depends on what is your what is the shape of your hyperbola. Okay, next from that is let's say we draw a rectangle. So then why we need this rectangle? Because this rectangle is the guideline for you to draw the asymptote. Okay, so sketch the diagonal of the rectangle and extend. So then this is the asymptote. So how you want to sketch this asymptote? You look at your rectangle, you have the edge here, okay, and then you joining these two diagonally through your center, and then you use the ruler, make a long line, so that is called your asymptote. Okay, then you draw the each branch. Okay, since both of them are asymptote, okay, so means that the hyperbola branch, you cannot exist the boundary of your asymptote. Okay, then after you already sketch everything, don't forget to put our foci. So how to calculate the foci? Actually is c squared equals to a squared plus b squared. Okay, so where you want to put your foci? Following your vertex. Okay, so vertex is foci is always a little bit further from your center. Okay, so if you have a center, the next you will meet actually will be the vertex, then you will meet your focus. If your horizontal vertically, then this is your center, then you will meet your vertex, then you will meet your focus. Okay, then so then you put your focus. Okay, so then after that, okay, if the question requested you to find the equation of the asymptote, please please calculate the equation of your asymptotes. Okay, so this one actually is the summarize of the previous one. First one, always put in a standard form. Okay, so then you need to determine the shape. After that, I identify the center, and then you calculate the length of the horizontal and this one is horizontal and vertical axis. Okay, after that, why you need this one actually is only for drawing the box, the rectangle, and then we calculate our vertices, draw the rectangle. After that, sketch our asymptote, draw the branch, and locate the foci and the equation. Okay, so let us look at the first one. Let's say we have a simple hyperbola, y squared over 64 minus x squared over 36 equals to 1. This is almost a standard form, but the only thing that because this is a 64, so we change it to become b squared, so it's x squared, and our a actually is 36 actually is 6 squared, so we have a 6 power of 2. Okay, so once we already put in a standard form, the next thing we want to know, what is the shape? Okay, since our y is in front, so it will be vertical or the one open up and down. Okay, then after that, the thing is already said, our center is always HK. If you cannot remember, just recall our Cartesian coordinate, always x is in front, so you look at x and you look at y. What is it? Actually is 0 0. Okay, y suddenly have a 0. Remember, y squared actually is y minus 0 squared. They are the same, and this is why it must be a minus. The main reason is you learn during the quadratic, when you finding factor, okay, x minus 3, we said let equals to 0, so x equals to 3. Okay, so that's why this one is always a minus, because later on we want to find the root of it. Okay, then after that, we already know our center is 0 0. Then we need determine our a and b. Okay, for this one, easy purpose, a always below my x, b is always below my y, so my a actually is 6, my b is actually is 8. Okay, before we go for the calculation of others, so we can see how we're going to sketch our hyperbola starting from center. Okay, center is 0 0, and it said that is our b is 8, so you move 8 going up. Okay, why it going up? Because 8 is for the length of y, so 2 4 8 2 4 6 8, then we have a 2, sorry, 2 4 6 8, so we have 2 here. After that, we have our length of a. Okay, that doesn't matter when you want to start here or here. The only thing is I know that from the x value from our center is 6, so 2 4 6, so 2 4 6. Okay, so this length is 10, this one is 6. Okay, after that, what you do, you use the ruler, join all this one going down to where until the 1 8. Okay, so you're going to have one rectangle. Okay, so after you have this rectangle, what you do, use the ruler, joining these two edges diagonally, okay, and cross our center. So we have this one, then we go here. Okay, so our asymptote is ready. Okay, now maybe you're going to ask, then what's next? Okay, so means that we need to identify where is our vertices. Okay, so because of we already know this is an up opening up down, so means that this point, okay, this point, the first I put actually is your vertices. Okay, then how you want to sketch the the curve of your hyperbola? Start from your vertex, okay, the upper one, go. Okay, when you see your asymptote turn up, so happen here going up. Okay, so for here also the same, you're going down. Okay, and since I already have all my above vertices, then I need to know to put where is. Okay, so vertices we just label as V, center with label as C, so this is V2. Okay, so now we need to sketch our focus. So what do we do for our focus? Before you want to label your focus, you need to calculate the C. Okay, c squared equals to a squared plus b squared, or our c actually is a plus minus of a square root of a squared plus b squared. So over here actually is plus minus 10. So means that you calculate from the center going up. Why is going up? Because this is an open up and down hyperbola. So it will be going up for 10. So just now this is 8. So this is 10 here. This is negative 10 here, so this is my focus 1, this is my focus 2. Then actually the sketching of your hyperbola is already finished. Okay, then because of this one, we calculate our asymptote also. Okay, so just put follow the formula y minus k. Since our k is 0, so it's my y minus 0. Okay, b is the one follow our y, so it's 8 over 6 over x minus 0. Okay, so then simplify, so we have y equals to plus minus 4 over 3 x. Why there is a plus minus? Because we have a pair of the asymptote. Okay, so let us, okay, this one is the animated one. Okay, so it's like this. Okay, then let us look at the second one. Okay, so the second one is similar like just now. The only difference now, the x is in front. Okay, so when x is in front, so it is horizontal. Okay, so when it is horizontal, so it is a butterfly. Okay, then the center you took from where? Okay, HK, so it's 3. Okay, although this one is y plus 2, but the thing is the formula is y minus, so you change it to become y minus minus 2, so you're going to have 3 minus 2 as your center. Then, as usual, the one following your x is A, the one following your B actually is your B. So my B is 4, my A equals to 6. Okay, now, just now I didn't discuss what it means by our vertex and the calculation over here. Okay, so this thing, if you want to following the calculation here, you need to remember, okay, when you have the form, okay, if you have the form of the horizontal, okay, so your formula will be h plus minus a. Why is only h plus minus a? Because the calculation is based of our center going to left, right, so that's why it's plus minus for the location of the x, plus minus a from the center. If the previously is the horizontal, is the vertical one, so means that your x is never changed, you only changing your y, so the formula will become h k plus minus b. Okay, and this is not A, it's a B because we're following the alphabet below our Y. Okay, so there are two ways. One way is like just now, what I did is I calculate based on my picture. Okay, so I can know my vertices. Then, or another way, you can calculate the vertex and foci beforehand. So after the calculation, you know that is okay, so let's say this is 3 2. Okay, so then you know that this is 3 2. Then you want to plot your vertex, you can base on this one. Okay, you can base on these two things. Okay, so you find where is the 9. Okay, 9 2, let's say is around here, -3, -2 is here, so you already know this is your vertex. Okay, but the thing is but the thing is when you want to make the box, okay, so maybe you can know it's around here. Okay, because this is the border of your rectangle, but the thing is over here you still need to calculate 4 over here because the height is always for the B. Okay, so that is the thing. Okay, so then you have to weigh. Okay, so let's say you are based on the one in vertex, so 9 and -3. So then you go for the 4 above and then 6 6 for the length. Okay, so you make a box. Okay, then you draw your two asymptotes. Okay, then after that you can calculate your 2 for chi. Okay, then after that for chi, okay, if because of 2 set -13, we don't know what is it, you can use the approximate value is about 7.2, so it's a bit, just a bit longer than the 6. Okay, then after that you sketch the curve. Okay, remember one thing, that is the curve is for vertex, the curve is not for the foci. Okay, and then after that, as usual, calculate your asymptote. Okay, but now our k and h are not 0, so if you want to have the final version of your asymptote, remember this is plus minus, so what you need to do is y plus 2 equals to 4 over 6 x minus 3. So you multiply, then you will get this one. Then the second asymptote will be y plus 2 equals to -4 over 6 x minus 3. You expand this and then you do simplification, you will get the second one. Okay, so now we go to the third example. Okay, now the third example, if you notice, the right hand side is no more 1. So your duty is, first thing is quickly make the 64 become 1. How to make it to become 1? Then we divide everything with 64. So when you divide 64, actually this one actually is 4 over 16. So you have 1 of x squared over 4 squared equals to 1. And since my y is in front, so it is vertical, and since this one is y minus 0 and this one our center is 0, 0, so then B and C, so then all these things you can make a hyperbola. Okay, then now we look at one more example, which is a little bit more complicated compared to the previous one. That is, this one is called the general formula for the hyperbola. Okay, so then you can see that is from here you cannot tell. Okay, I have to remind you from here 4x squared minus 9y squared and so on, you cannot tell this one must be horizontal or vertical, because you cannot tell from the general solution. You only can tell whether it is a general hyperbola which is a vertical or as horizontal, with the condition you already come into a standard form. If it is not a standard form, you cannot make any conclusion. Okay, so how you want to go to the standard form? So what you need to do is you need to do the completing the square. So while doing for the completing the square, just now we see that is x with x, y with y, then the one without any x or y, you throw it to the other side. So first thing we don't want actually is our 113. So we shift it into the right hand side, and then we collect our x together, then our y together. Okay, the one with the same same alphabet will play together. So for the x is easier. So since I factor out the 4, so I have an x squared minus 2x. Okay, then we go towards the next one. Okay, so since this is minus 2, so 2 over 2 is 1 square minus 1 square. Remember, don't forget to minus. Okay, then actually after that, the next actually is expanding our bracket just now. So 4 multiplied minus 1 is minus 4. Okay, so actually this one, our completing the square for the x is already completed. Okay, now for the y, please pay a little bit attention for the calculation, because if we have a 9y squared plus 54y, okay, so when I want to do factorization, when I want to factor out my minus 9, so remember this one is y squared minus 6y. Okay, it's not a positive. Please don't be careless. Okay, this is a minus 6y, so you're going to have a y squared minus 6y here, and then you can do as usual, y minus 3, y is 3, is 6 over 2 is 3, so y minus 3 square minus 3 square. Okay, regardless this is positive or negative, we always minus 3 square. Okay, then over here also we you expand, so you get your completing the square also finish. Okay, one more thing, because this expansion is come with minus minus, that's why this one is positive. Okay, then both of the x and y completing the square is finished. What you do is you just move the one without y towards the other side, so we have a 36. So now everything is clear. The xy is on my left hand side, the one without anything is on my right hand side. Okay, then the next thing is you think in your mind that is, ma'am pernah kata the right hand side must be equals to 1, so you divide the 36 with 36, so everything divided by 36. Okay, so this is 1, so everything divided by 36, so this is actually is 9, this one actually is 4, so this one is the standard form. Okay, so now since after we already definitely is already in our standard form, now you can say that is, since our x is in front, so it is horizontal or left right, or we say that it is a butterfly. Okay, and when we look at it, the location, okay, the coordinate following our x is 1, this one is 3, so our center is 1 3. the one below our x is 3, so then below our y is 2, so this one, the a actually is 3, our b actually is 2. Okay, then if you want to use this calculation to calculate your vertex, okay, since this one is butterfly, okay, is a butterfly, so you going into invert, okay, going to the left and right, so that's why you have an h plus minus a, and then the foci is h plus minus c. Still remember how to calculate your c. C actually is plus minus square root of a squared plus b squared, okay, and as I said just now, cert 13, I don't know what is it, so we use the approximate, is about 3.6, so for the easy calculation. And since we have our asymptote, okay, so now y minus 3, okay, is take from here, x minus 1, and then the value below our y actually is 2, so we have a 2 over 3. Excuse me. So if you want to get the right hand side, so you expand the calculation. Okay, so this one, if you have time, you can sketch on the right hand side. Okay, so this is the exam, this is some of the practice. Okay, so if you see this one, so that means you need to do the completing the square. So now we look at another types of question can be asked. It's not only sketching. So let's say they ask you a question. They said a hyperbola has a focus at -4, 0, and the vertices at -4 and -4, 4 and -4, 2. What is its equation? So what is the hyperbola equation? And they ask you to graph the hyperbola. Okay, so it's quite easy. Means that because we cannot guess, or I'm not encouraging you to memorize anything, so if people give you any information which you can draw, you just draw it. So let's say this is our xy axis, so -4, 0, okay, this is -4, 0, then is it -4, 4, so 1 2 3 4, and then -4, 4. Okay, this is our vertex. This is said is already is our focus, and then the next one is said that the next focus actually is -4, 2. So this is our V1, this is our V2. So, and then these 3 points they're giving to you. Okay, since you already know that if you only have 2 types of hyperbola, either is vertical or horizontal. Okay, so if they are fall into one line, which this line is parallel to your y-axis, so means that your hyperbola must be a up down. Okay, it is impossible left right, because vertices is the one your hyperbola must pass through. Okay, now then once you already know that it is an up down open up down hyperbola, or our horizontal our vertical hyperbola, what you need to do, what is the standard equation, standard formula for our up down hyperbola? So actually the y is come first, y minus k square over b square plus minus x minus h square over a square equals to 1. So this is the first thing you know. Okay, then after that, then you look at it. Okay, the equation needs center. Okay, as you know that center must be in the center of everything. So if you have 2 vertices and then the center of it is here. Okay, so actually this one is 2, this is 4, so the center of 2, the midpoint between 2 and 4 actually is 3. Okay, then what is this one is y, what is the x? X never change because they will be 4 at the same line, so you must know that your center actually is -4, 3. So you substitute back into this one, so you know that is your y is 3. Then because your h actually is -4, so then you're going to have y minus 3 square minus x plus 4 square. Okay, so this is x plus 4 square. This is equals to 1. Okay, now the next thing you need to find actually is a and b. Okay, how to find a and b? Okay, since this one is an vertical, so you will know that the length of the b must be from your center towards your vertices. 2 to 3 or 3 to 4 actually you know is 1 unit, so then you put down here is 1 square. Okay, whether you want to put 1 or 1 square, it doesn't matter. Okay, they are the same. Okay, after that, now we have a problem to find a, because you don't have the length. Okay, you don't have the length, you only have the height. So then, but the thing is, they provided you the focus. Okay, they provided you the focus. So what is the focus? The length of the focus actually is c. Okay, so you straight away recall c square actually is a square plus b square. What is the c over here? Actually is the length from your center. Okay, the length from your center to, okay, sorry, from the length of your center to the focus. Okay, the center is 3. Okay, and then this one is 0, so this length actually c actually is 3 square equals to my a actually is 1 square plus my my a tak tahu. Okay, my b actually is b is the one with 1. Okay, is it my c is 3 or yes, it's 3. Okay, so is okay, so now then how to find c? So it's 9 minus 1. Okay, 9 minus 1 equals to a square. So actually your a is 8. Okay, so plus minus 8. So then you just put here 8. Okay, sorry, it's b here. Okay, so it's put 8 square. Okay, so your hyperbola is finished. Okay, then later on, you based on the this type of things, you can sketch your hyperbola. Or actually, basically, this one is almost complete. The only thing you need to make the box and then put the asymptote, and don't forget another one foci. Okay, then let us look at the next question. Write the equation for a hyperbola with x-intercept at 5 and -5. The foci 6, 0 and -0, 0. Before you can think of what it means, what we just do, okay, okay, it said 5, okay, 5 and sorry, this is -5, -6, 5 and 6. Okay, so from here you can see that it said the 6 actually is foci. Okay, and you said the hyperbola must pass through. Okay, so indirectly you already can know that is the 5, 0 and -5. Okay, x-intercept means is you intercept as a 5. Okay, so from there you already know that is this one is the 5, 0 and -5, 0 is your vertex. Why you can confirm that? Because we only have a horizontal or vertical hyperbola. We don't have a hyperbola which is have a 45-degree okay, with your axis. We don't study that. Okay, we only had studied either you're going to have a horizontal or vertical only. So from here you know that it is a horizontal hyperbola. So when this is a horizontal, so you will directly you can tell this is x minus h square over a square minus y minus k square over b square equals to 1. Okay, so then from here, after that, we more interested into the center. So from here, this diagram you can easily can see actually your center is 0, 0. So you just put 0, 0 here. Okay, so how to find the A or B. Since this is a horizontal, you will know that is this one is your A. Okay, so this one is your A, so your A is 5. Okay, so how to find your B? Remember, the center to your foci actually is C, so we still using the C square equals to A square plus B square, so you can find your C. Okay, one thing that you need to remember, this one is not an ellipse. Okay, ellipse is the one who's going to determine your shape. Either your shape is membujur ataupun menegak, but in hyperbola, we don't care about what is the length of our AB. The one who determine our length, our shape actually is the who is in front. Siapa yang tolak siapa, okay? Next is the hyperbola center as 30. Okay, so this one is already telling you a hyperbola is the center as 3, 1. So 1, 2, 3, this is 1. And it's open left, right. So open left, right. Okay, so like that. Okay. Then has an asymptote with slope 5 and -5. Okay, this unfortunately, this one you cannot calculate from here. So what you need to do, since it's open left, right, so your brain straight away need to produce x minus h square over a square. Okay, then minus y minus k square over b square equals to 1. Since it's already provided the center is 3, 1, so then you change it to become this is 3, this is 1. Okay, then your duty to find a and b. Okay, then it said that the slope. Okay, so how to find the slope? Then we have our asymptote y minus 1. Okay, this one equals to plus minus b over a x minus 3. Okay, so actually this one is your asymptote, so you know that b over a is equals to 5 and b over a actually is -5. So then you can produce what is your a and b. Okay, then after that you have another one. Okay, so this one is more tedious. Okay, find the equation of the horizontal hyperbola that has this one. Okay, this one you have to rephrase back. Okay, you try to rephrase back into y minus k equals to plus minus b over a x minus h. So you can roughly get your hk and b over a. And then we have one more. Find the equation of a hyperbola that has a y-axis as a transverse axis. So if y as a transverse axis, so means that you are open, up, down. Okay, and then it said the center is 0, 0 and passes through 0, 5 to 5, 2. Okay, this key that you please remember that is when we said that when have a line, a point. Okay, let's say have a point. We said our point is 3, 4. Okay, when it said passes, okay, passes y equals to 2x plus b, or it can say that a point 3, 4 go on the line y equals to 2x plus b, both are the same meaning, which you put your 3, 4. So when you have y equals to 2x plus b, so you put y as 4, x as 3 plus b, so it must fulfill. So this is the way they let you to find your a, b, c, whatever alphabet. So your b is -2. So the below one exactly is the same thing. So that is the information we have. Okay, so now since for these cases is open, up, down, so I'm going to have y, my center is 0, so is y square over a square. Okay, sorry, it's b square over x square over a square equals to 1. When it passes to 0, 5, so you substitute inside. Okay, so y is, okay, passes through 0, 5 means that 5 square over b squared minus 0 squared over a squared equals to 1. So means that your b actually is 5. Okay, then after that you use the second point. Okay, you use the second point. What is your second point? Let us see. So your second point will become y is 5 sub 2 square over, just now we already know this is 5 square, minus 2 square over a square equals to 1. So from here you do some algebraic, then you will get your a. So then you already get your hyperbola. Okay, and then we have the question 12. Find the equation of a hyperbola whose vertices at 0, -3 and 0, 3 and have first walkers. This one is almost like the one in the the first of this type. So first thing you sketch it. Okay, so 0, -3, 0, 3, then you have a 0, 5. So from here you can roughly can guess this one must be x is in front, and then you calculate this one the a, then this is the c. Okay, then okay, so actually your chapter 3 is finished. Okay, so in what is actually inside your chapter 3, the first thing is you need to know, okay, the first skill you need to know actually is completing the square. After that, you put, by using the completing the square, you put it in a standard form. Okay, this standard form is either depend of x minus h square over a square minus y minus k square over b square equals to 1. Remember this one is 1. Or the other way, y minus k square over b square minus x minus h square over a square equals to 1. Okay, so why this one is important? Because this one is determine the shape, either butterfly, buka kiri kanan, or we can it as a horizontal, or the second one is the one we say is vertical, is the UV smiling and the sad face, ataupun you can say this. Okay, so this shape, and one thing is, doesn't matter what is your shape, the one in the middle is called center. When you have the, if a horizontal, then they must have all the points must be as in on the line parallel to your x-axis. Then the one open up and down must be parallel to your y-axis. Okay, and remember the one joining the vertices are called transverse, and the one complement is called conjugate. Okay, then don't forget you have a foci. Okay, then you have the asymptote. Okay, then one is I never mentioned actually is the length of lattice rectum, so you just calculate following the formula. Okay, and then after the sketching, the one part is the one is they give you the information, you change back into the formula. First thing is always try to identify what is the shape of your hyperbola. Then after that you start doing some drawing or whatever, then you can get your hyperbola. Okay, so your chapter 3 is finished.